Hello, everyone. I'm OpenCV CEO Dr. Satya Malik. On today's episode of OpenCV Live, we welcome back our friend from the last ARM-focused episode, David Boriski, and a new face, Mark Horvath. They join us today to show us the big performance gains possible with OpenCV 4.11, with a presentation on how to accelerate an OpenCV-based Android application with KleidiCV. I'm very excited to see what they have us for today. But first, as always, with me is OpenCV's Director of Content and Creative, Phil Nelson. Phil produces the show, and if anything goes wrong, it's his fault. Hi, Phil.
Yes, good morning out there, Satya, and everybody watching in the chat. It's me, it's PHILLIP. I am your co-host with the co-most, the second banana, who's second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you, my dear friends, know that you can call me Phil, and I'm here to remind you of a few things that we do on every single episode of this here program. The first of which is a giveaway to you in the audience. Stay tuned. Later on in the episode, we will be asking a trivia question based on the presentation from our illustrious guests, and the first person to answer that question correctly here in Zoom wins the OpenCV course of their choosing. OpenCV courses are high quality, professional grade stuff, and we're giving you one away for free today. So stay tuned later on in the episode and we will hook you up with that. You have to be in Zoom to win. To get on Zoom, you can go to opencv.live wherever you're watching and pop into the Zoom chat. We're working on a way to make it so we can involve everybody else as well, but it's a process. It's a process. The other thing we do on every single episode of OpenCV Live is take questions from you in the audience, and we will do our best to answer them, as the late, great Satoru Iwata would say, directly. So please use the Zoom Q&A button at the bottom of the screen to ask your question wherever whenever you have it. We'll do our best to answer them during the show. We're also going to save some time at the end of the program to get to those questions that we didn't get to. Or if you're watching us on LinkedIn Live, you're watching us on YouTube, you're watching us on Twitch, ask your question in the chat over there, and I will do my best to surface the good ones here on the live stream. But before we get started with the proper program, there is just a little bit of housekeeping to do up front at the tip top of the show. Doc, would you like to tell everybody how they can support OpenCV, a nonprofit organization that produces open source software that people can use for free?
Yeah, so there are several ways of supporting OpenCV. As an individual, you can donate to OpenCV directly using our PayPal link, or we have a couple of options there. But yeah, right there. So you can use donate. You can use donate using Stripe or PayPal, whichever is convenient for you. You also have the option of suggesting to your organization to become a member for OpenCV. And we have three membership options: gold, silver, and bronze. And ARM is, for example, a gold member of OpenCV, and this helps us support the library. Most of the, more than 90% of the donation actually goes towards the development of the library itself. So please help us. You can also buy some merch from OpenCV. Before that, actually, GitHub is also an option. If you are on GitHub, you can go and directly, donate here. Phil, would you like to just
Shout out to our GitHub sponsors. I've never once gotten a message from any of these sponsors. So I don't know if they care about this at all, but I'm doing it anyway. Shout out to our GitHub sponsors, Ecosystems. We love to see it. Jaws, apparently, Runja Lee, DJ Greenwood, been here for a while. Arudis Laboratories, quite a long-time sponsor as well. Talha Hussein, Dominico, Silent Wolf 27, sick username, Pedro. RoboFlow, the homies. We've got Alexander Ismailov. We've got Nick Libertini. We've got Blue Jay. We've got Jesus Anaya. And we've got Victor Vervato. Thanks so much, everybody. You too can sponsor OpenCV by going to github.com/sponsors/OpenCV for just $9 a month. Get your name in the current sponsor list. Eventually join the proud ranks of the past sponsors, perhaps, and help out the essential infrastructure for the CV and AI communities and industries. That is OpenCV. You can also buy a T-shirt. Maybe you've got a body, right? Your body needs clothes. It's a harsh, tough world out there, and you can buy some of these designs to show your support for OpenCV and protect your fragile human body from the harsh climate outside. We got the Import OpenCV T-shirt. We've got the OpenCV logo and the most popular design, I love OpenCV, in English, simplified Chinese, and en Espanol for folks that speak them languages or write them languages or whatnot. You can buy them in hoodies, t-shirts, we've got pet bandanas, we've got stickers, we've got pins, we've got tote bags, just like NPR, only we're way, way cooler than them. There's one more big bit of information here, Satya, that we really got to talk about, and I'm excited to bring this up. They put the video on the site. Did you know this?
All right, that's great.
Yeah. So can you give the folks a quick pitch about the Computer Vision and AI conference from OpenCV and SID?
Yeah, so the Computer Vision and AI conference, this is being organized in collaboration with SID. It's called Display Week, and we have a full one-day event on May 12th, and I'll be talking there. There are several luminaries from across the industries. They will be talking, and in collaboration with this, I also have a tutorial on image segmentation during this event. Not on May 11th. I think it is on May. Not on May 12th, but it is on May 11th. But this full day event also is, it's the first time OpenCV is organizing this full day event. So please, if you are in the Bay Area especially, please join us. And if you're already planning to join Display Week, right, if you're going to Display Week, please add this to your list of things to do at Display Week as well.
Yes, OpenCV will also have a booth in the exhibit space during Display Week here. We're really looking forward to seeing folks there. We'll invite some of the OpenCV member organizations to join us at the booth as well. So come by there for some exclusive conference swag. We'll have probably some stickers. We might do some giveaways down there at the booth. Some of our partner organizations may do the same, so come drop by. I know for sure we'll have some of the fresh stickers from our homies at Ross. So feel free to please stop by. You can come see the general schedule. You can register to attend on the displayweek.org website right now. We're going to release more information about this very soon on the OpenCV newsletter and on our website. You can visit displayweek.org. Watch the little pitch video here from our very own Dr. Malik. I think they did a great job of punching you out from the green screen, Doc. What do you think?
Yeah, that's right. And I'm also wearing a suit because these days
right.
people expect you,
because you're a professional, right?
People ask you at news conferences, where is the suit, right? Why are you not?
How come you're not wearing a suit?
Yeah, so I decided I'll comply.
Yeah, it's malicious compliance. It's with that suit. All right. Having said that, I think now let's get started with our presentation. Huh? I think I'm done yapping here. We talked a little bit too long.
All right. So David and Mark, welcome. We are very excited to hear about this. We have already discussed that we have been working with ARM for a couple of years now, and all this, all the work we have done together is bearing fruit. Now OpenCV is super fast on Android platform, especially when with our ARM architecture. So I would love to first go start with an introduction. If you could briefly introduce yourself, and then we will go over the presentation on how to speed up OpenCV applications on Android.
Okay, then I start first. I'm Mark Horvath. I'm a staff software engineer at ARM, and I'm component lead of the KleidiCV library.
Welcome, Mark.
Welcome. So thank you very much for having me one more time on this webinar series. My name is David Borycki, and I'm a passionate software engineer. I used to work with OpenCV for more than 10 years already. So I mentioned last time that is for one of my research projects, I used to use the OpenCV for object tracking. Actually, it was for very very specialized images. So I found like the algorithms implemented in OpenCV very useful and robust for this kind of problem. And since then, I use like OpenCV for all the problems I have with like computer vision. And today I will show you like after Mark will like introduce the ARM extensions to OpenCV, how to apply them to the actual Android application to speed up like typical image processing algorithms you can meet in the computer vision.
Fantastic. I think go ahead and get started, fellas.
Okay, thank you. On the bottom.
Yep, and as a quick reminder to the folks watching out there, we are taking questions from you in the audience. Wherever you're watching, go ahead and drop them in the chat or use the Q&A button here on Zoom. It helps us, just keep track of everything a little bit more easily. So thanks. That's good. Go ahead, Mark.
Thank you. Yeah. So I will just to give you a little short introduction just to set the stage, David. Sorry. We did our previous webinar, I think we mentioned in the beginning, where we talked about the history and the partnership, but I will just give you a very short recap to set the stage. So ARM is a global semiconductor design leader, and it's providing compute platforms on basically any device you can think of. We have 20 plus million software developers working for ARM, and those developers are targeting those 300 plus billion base chips a day. We have more than 1,000 technology partners, and that number involves the big names you can think of, like Google, AWS, MediaTek, Tencent, Alibaba, so all the big names there. ARM was founded in 1990 by 12 engineers in a little barn next to Cambridge. Our first major success was the role we played in the smartphone revolution in 1993. The role was to deliver secure and power efficient processor designs for these handhelds. And today, ARM is securely powering any product, from small sensors to smartphones to supercomputers. And we're delighted to say that currently all major cloud providers has ARM-based instances like Microsoft, Google, AWS, NVIDIA. And those 30 years of experience in power efficiency helps us a lot to be there for the AI revolution and to power all those AI workloads happening today and probably will happen soon. I mentioned our role in the smartphone revolution, and actually it's fair to say that now 99% of smartphones are based on ARM, but ARM needed to put a lot of effort to achieve that. So in just the last decade, those handhelds, the compute performance on those handhelds were improved by 110x. So the guys working hard to make it possible.
It's a big difference from the Apple Newton to today, I would say.
A few years and few X's for the performance. Yeah. And today, ARM with these technology partners helps the developers to create the future experiences on mobiles. So you can think of new camera pipelines, gaming experiences, and all the AI-related story. So like text-to-audio generation, multimodal models, or enhanced chatbots. And the idea here is to run those models on your device. And if I can just mention one thing, for privacy reasons, it makes sense to run those models on your device. And on the right hand, you can see a short video of a technology demo, which was created by ARM and was shown last week in the Mobile World Conference. So you can see the user can drop into this kind of chat pictures with some questions, and the AI model behind analyzes both the image, both the message and comes back with an answer, and it thinks it is running on the phone. And so one of the technologies which help achieve these AI goals is the new things in our latest architecture, so in ARM v9, which gives even more power efficiency for our CPUs and gives nice vector instructions and matrix multiplication instructions to help you speed up the calculation-heavy parts of these all workloads. And we introduced ARM KleidiCV libraries to support these new technologies and give access to seamless access to these CPU the CPU performance. So the idea behind ARM KleidiCV is to give small, lightweight libraries with these computational kernels. So with the compute-intensive parts of these for these AI or CPU workloads, and give it a format that is very easy to integrate. So as few dependencies as possible, the not permissive open source license. So, and we are actively looking for partners and looking for frameworks to integrate these libraries. And once those integrated, those are unlocking these ARM architecture features and enabled our optimizations without any effort from the developer. So if you're already there on that framework, once it's updated, you get the nice performance uplift for free. And these are focusing on CPU capability. And so with KleidiCV, you can ensure that your code is portable and your acceleration are seamless on those CPU generation and CPU-based devices. Okay. This page shows our current story with the integrations. On the left is KleidiCV. So KleidiCV is a computer vision library, gives you simple computer vision algorithm, sometimes simple, sometimes complex, but the core functionality of any computer vision processing task. And we already integrated into OpenCV. A little more on that later, but we also wanted to share that KleidiCV AI, the kind of the brother or sister of KleidiCV, is already there for speeding up AI-based workloads, and that it's already integrated to these AI frameworks. So if you're using these frameworks and you update the latest version, you can see that you have a nice performance uplift on ARM-based devices. Yeah, the ARM OpenCV partnership started 2 years ago. We were introduced because OpenCV has a thriving open source community. Also, when we talk with our AI and ML friends, they mentioned that if anyone wants to do some image-based AI, the first thing is computer vision part, and that's usually done on OpenCV. And we also understood that or faced that OpenCV is there for any conventional CV bits, but it's a default choice for many people out there to use OpenCV. So with this partnership, we are meeting the developers where they are. We didn't ask any unusual. You just need to still use OpenCV. One of the first milestone of this partnership was this Maven repository upload. So we worked together to upload an OpenCV Android OpenCV build to Maven, and that we felt that was somewhat a gap. And with the Maven repository, you can easily deploy your OpenCV based application on Android. You just need to pull in the package. David will show you how to do that. On this January, with OpenCV 4.11, KleidiCV is turned on by default for Android, meaning that if you are working on running your workload on Android and using OpenCV, if you download latest greatest 4.11, you already can see our performance uplift. And for next steps, I can mention that we want to broaden the operations. So KleidiCV also a young project. we have a never-ending list of operations to add to broaden what we support. Currently, we have some color conversion operation between YUV, RGB, and some filter-based like Gaussian blur and Sobol filtering, and also some resize operations that we would like to extend it with more perspective and remap, median blur. So we've tried to look for the operations used in the wild the most. And also one other thing we are looking for is to enable KleidiCV on by default on Linux as well, similarly with Android. And that can target these small meshes like Raspberry Pis, Banana Pis, that kind of stuff. And if we enable us on Linux, it also means that we enable them for Linux OpenCV, Linux Python packages for AR64 as well. Lastly, I would like to talk just a word about our ARM developer program, which is a 2-year-old thing. And the aim is to give resources for any developer targeting ARM, so technical resources and educational materials. Those you can find on the ARM Developer Hub, which is a site behind this, or you can sign up to the developer program. There you can meet with and talk with ARM experts, so internal engineers. You can connect with the wider ecosystem as well. We also have ARM ambassadors who are leaders and experts of their field of technology, and they are advocating ARM. We have also Discord channel, and you can become a member if you check this QR code here. And with that, I'm delighted to pass you over to David, who is one of our ARM ambassador, and show you a very interesting demo, I guess. So it's over to you, David.
Thank you, Mark. So let me share my my screen now. So yes, so pretty much I'm going to show you today how to pretty much like apply all the stuff that Mark has described into the actual like application that you can build for Android. And pretty much all the source code that I will be showing today is like available on the GitHub page, and we also have like a learning path about this, so anyone can go through this in their own time. And basically, the plan for this presentation is that I will provide like a short intro. I will tell you how I build this Android application, how to add OpenCV, and how the KleidiCV is automatically enabled. And then I will show how this application is actually like working, and what kind of like speed ups we will expect when we use KleidiCV or not in the application. So pretty much for the app, I used Android Studio, and I started with this like project template for the empty views activity, and I set the project name to ARM64 KleidiCV demo, and set up like a minimum SDK and a language to programming language to Kotlin. And then once you do this, you will see that you will start with like a project template. And the second thing was to create some user interface. So in this specific case, I pick up like some image viewer into which I load like a cameraman image. Of course, you can use any image you want. And then I have like a drop down, which enables me to like select the image processing operations. So here the drop down shows the Gaussian blur. And when the user clicks the process button, it will pretty much run like n times the specific image processing algorithm on the cameraman image. And then I have a few text boxes here that will describe this processing performance. So I'm running it typically like 1000 times in order to have enough statistical input, so I can calculate like average processing time, mean, max, and the standard deviation to pretty much analyze how the given algorithm was like behaving on a specific library. And with this, I will be able to demonstrate what kind of like performance improvements you can get from the from KleidiCV. So in order to add OpenCV to the Android app is now straightforward, I would say, for anyone who used to work with like C++ version. You don't need to like import CV2, CV2 as on those like HADIs you guys were like showing. By the way, they are very, very nice. I think I should get one. Also, I think you should consider having one with like imshow because this is like the function you typically call. So
that's a fantastic suggestion.
yes. So pretty much although you just need to add like a one line of code to your like dependencies section. So here I'm like adding this OpenCV 4.11 for which the KleidiCV is already included. So it takes like some time to download the binaries, but then the project is pretty much ready to go. And you don't need to do anything more. The KleidiCV will be ready for you. So it's really straightforward for the developers to add OpenCV with the KleidiCV support. All this will go through the Maven repository. And then you pretty much like follow this this step where you need to initialize OpenCV. So you typically use like this like init local method from the OpenCV loader to initialize the library, and then you can start using this. So here in this application, I try to make like an architecture more formal. So I try to separate the image processor, which enables us to like perform those like image processing operations from the UI and from the actual like backend class. So I have this like image processor, which takes this apply operation. It's like an interface, so it will like given the specific image operation, it will like apply it to the source and destination mat objects. So those are the typical objects we use to represent images or matrices in the OpenCV code. So this is an interface that I use to glue the backend code with the UI. And then I have an actual like image operation enumeration, which implements all those operations that I have in this dropdown. So here I'm showing this Gaussian blur, Sobel filter, resize, and this also gives some like idea of how to like use those functions. So pretty much for the Gaussian blur, I need to provide a source and destination mat with some parameters that specify my filter size. And for this specific demo, we adjusted like all the parameters to achieve like the best performance possible. So this is like the one of the things you may need to experiment with when you are working with KleidiCV, that for some specific parameters you can get like a better or lower performance, and it's like this is something what Mark has mentioned. The team is working to improve to pretty much make it more general. And then I also have in this application the performance metrics that enable me to like calculate all those like values that I display here in the user interface. And here I have like a few examples of the application, how it will work. So it can also do the rotations and the Sobel filter. And for all this, I'm displaying like the average processing time, minimum, maximum, and the standard deviation. And then pretty much I compare it for like the cases where I have a KleidiCV included and not, to pretty much like confirm this like up to 4 times improvement in the performance. So pretty much to like compare this KleidiCV enabled code to non-KleidiCV, what I did, I downgraded OpenCV to 4.9 because it was the version without the KleidiCV support. And those results are presented on the right. So as you can see that pretty much the average values are like between 3 to 4 times longer when we run the same code without the KleidiCV.
That's great.
And
There's no
gains.
difference in the actual code. It is the exact same code. All you have to do is upgrade to OpenCV 4.11, and your Android application suddenly many functions become 3 to 4 times faster.
Exactly. That's correct. Thank you very much for this comment. That indeed, no code changes, same application, just like change the version of the OpenCV to the one which has KleidiCV enabled, and you just get this like nice improvement in the performance. Yes, and this is what I'm.
What more could you want as a developer? Things just get 4 times faster for free. It's great.
Exactly. So yes, that's how ARM has made all of us very happy, because no need to change anything and just enjoy the faster processing times. So this is like the key point of this. Of course, as I mentioned, there are like some limitations that of course this improvement will depend on what kind of like operations you perform, how you select like the Gaussian or the filter sizes, that it depending on the filter size it will like provide more or less performance improvement. So I listed some of those like limitations in the slide, just to like highlight it, that this is like still a work in progress, and I expect those limitations to be reduced in the near future. But just to be like completely fair, this is something that developers have also need to keep in mind, that performance may vary depending on the actual operations they perform. So now I guess that we are pretty much ready to jump into the code.
One question I have, if you go back to the previous slide, it says that the Sobel output type must be 16 as C1. Now, of course, even if you don't put in that particular type, it will run and at a slower rate. Now, the question is there a way to know at runtime whether KleidiCV was activated or not, right? Or it is using the fallback C++. How do we know which functions were activated?
I think there is no easy way to know that. So basically, if you can, I guess you need to build your OpenCV version by hand and add some logs to something like that to attach to that. But there's a documentation in the KleidiCV repository which shows which operations are supported and for which parameter set. So we try to give the developers which parameter set to use to achieve best performance.
All right. Do you, by any chance, do you have that link? Can you share it with the audience?
Yep. I drop into the Zoom channel, and I guess feel them and propagate to all the audience.
All right. Yes. Thank you.
This was actually a very good question, because I also like when I was like building this the source code, I was like looking for a way to show it dynamically. So ideally, I would like to have like a checkbox which I can use to switch between like different versions of the methods. But indeed, it's like during the compile time that pretty much you need to like if you are building it yourself, you need to patch like the source code. And then this patch is like making changes to the OpenCV source code so that it will run more efficiently on the ARM devices after the compilation. So I was looking for the same thing, that ideally it would be nice to have this like runtime switch that will tell you whether you're running optimized or optimized code on your device.
Cool.
Okay, cool. So now I can go to the source code. So let me switch to the Android Studio. And yes, so this is how the app looks like. So I'm actually on this like build Gradle file, in which I can like select the OpenCV version. So I will toggle between 4.11 and 4.9 and then run the application to demonstrate performance improvement. But before going there, let me just like show you that the app is real. I have all those like application files solution. Also, here is my image. So if anyone wants to run this for a different image, they just need to like replace this file. And I also have some like activity main XML file which defines my layout. So I have like an image view, buttons, and those like drop downs, and in order to select the image processing operation. And then I also have this like code behind where I have this entire image operation, which enables me to like switch between specific operation, including Gaussian blur, sobel, resize, rotate. And I have this like image processor interface. And yes, everything is here in the repo. So let me now try to run this application. So I have my like ARM powered phone connected to the laptop, and I will run this application straight using this OpenCV 4.11. So what we expect is that we will have this this like better performance, because the KleidiCV is already available. And let me switch now to the screen in which I have in which I can show like my phone. So pretty much the first thing I'm going to do is to load the image. So now I have my cameraman image displayed in the image view, and then with this drop down I can select like the specific operation. So let's start with this Gaussian blur, and I will click process in order to run the operation. So I can do it multiple times, just to show that it will be like average time is like around 0.5 millisecond. For the sobel, it will be faster. So it's around like 0.2 millisecond. Resize is like around like less than 0.1 millisecond, and rotate is like around 0.20, 25. So now what I'm going to do is we can see that pretty much the application is quite responsive. Everything is happening quite like almost in the real time. And now we need to remember that everything is like going through the KleidiCV, so we expect this to be working so fast. And now what I'm going to do is to downgrade the OpenCV to 4.9 in order to disable all those performance improvements. So let me just like open my like build grader, and what I'm going to do is to like downgrade OpenCV. I need to click this sync now link in order to like download the specific binaries. So it may take a longer while to download them. So we need to be patient. But once they are ready, and so now they are ready, and I can pretty much restart the application. So let me do it now. And I'm going to run the same application. You see that I don't do any changes to the source code. As we discussed, everything is like is happening automatically. Let me now run the same application. So I start with the cameraman image, and let me like perform like Gaussian blur.
Oh, wow.
So we now see that the processing time is significantly longer.
Yeah.
We can see it even without like a performance metrics, right? That it's the app is like frozen for a few seconds before it performs this like 1,000 operations of the Gaussian blur. So the difference is like we can see it without even like performance analysis. Then let me do it for sobel. Here the performance is still like we can still notice it. It's like about 3 times according to what we like tested. And then the resize would be also like maybe like a smaller performance uplift. It's just to like demonstrate that that of course the amount of performance will also depend on the specific operation, because depending on the image processing operation, you can better tailor your code to be executed on the ARM architectures. So it's like with the GPU. If you like design your algorithm around the hardware, then you can you can optimize the application depending on the number of cores you have. So maybe let me do it one more time, just to or maybe I will run the application just to confirm this Gaussian blurring is working way faster. So let me reload the image one more time and see how
it was
slow this.
I thought it was
It's
still 4.9.
yes, it's still 4.9. I'm just trying to highlight how slow the Gaussian blur is.
Right.
And let me now change it to 4.11. Yes, I need to sync it again. I already had those binaries, so it's way faster. Let me rerun the application. Okay. I will show the app now. Let me load the image. And now Gaussian blur is way faster. So we see how much of the improvement we get from hard work from our engineers who developed the KleidiCV for us. So that's it. I hope that it confirms performance gains you can get from the KleidiCV in the OpenCV projects. And as we discussed, the major thing is that you don't need to do any changes to your source code.
Right.
The major job you need to make is to pretty much select the processing parameters so that you can get the most of the performance improvement available on ARM powered devices.
So one other question I have is, when something is optimized, often there is not a big bit exactness, right? It may be slightly different from the reference implementation. Does the document also mention whether the optimized version is bit exact or not, or slightly different?
Actually, that's currently not. I think we have some, but basically it's only about rounding errors. For example, I know by hand is, for example, with resize, you can have 1 bit of difference because of the rounding.
Right.
In case of Gaussian blur, the thing is that you need to specify if you are setting the sigma value, so the standard deviation of your bell, you need to say that, okay, I want it's fine for me to go with the approximation. So there's a hint parameter, and you can say, please give me the approximation version, and that way you can leverage the performance uplift. So we will fill that gap in our documentation to make it clear. There is not totally bit exact that, but as of now, it's just small rounding errors that you can find.
Right. Yeah, so that's pretty common, right? I mean, it's very difficult to get exact bit exact implementation, because sometimes very small changes which have huge performance gains, they are not exactly the same, right? It is
but so if something is done on floating point and you do the same in integers, and it's opens a new word for you that, okay, floating point conversations are really complex.
Right. And even floating point implementations can be slightly different, very minute.
Easily.
Yes, it all depends on the number of significant figures, as they say.
Yeah, not only that, but I mean, you'd be surprised that even now, every company, not every company, but large companies have their own floating point implementation, because based on the hardware they are going to run it on, based on several reasons, right? They don't use the IEEE standard internally for a lot of applications. Like Google Brain, the Brain floating point is one format, right? It is a floating point format, but it is not the same as IEEE floating point format, and so on and so forth.
Yeah. We've got some interesting questions here from the chat. Niraj would like to know, does the speed improvement that you're getting with KleidiCV will it affect the battery life and power consumption of devices?
It's a good question. So what KleidiCV use mostly is that we leverage these vector extensions we have, and running those vector extensions requires more power for you. On the other hand, if you're running it for a shorter amount of time, you are driving your CPU and all the memory subsystem, all those stuffs for less time. So you need to measure it basically, or I mean, so these are trade-offs basically. It can happen that your battery life is worse with that, but it can also happen that it's better with these optimizations.
Interesting.
I guess it's not too helpful answer, but I think that's the case.
No, but it's good to know, right?
Yeah.
Those are the two trade-offs. You're getting more power consumption because you're running it faster, but at the same time, you are also gaining some power because the whole system is running for a shorter period of time.
Exactly.
Yes, and a couple of folks have also asked in the chat about what hardware this will specifically work on. As you know, as we saw in the first slide, there's been literally billions, hundreds of billions of ARM chips shipped out there. And so I think I saw ARM v8 and up. Is that the target for these improvements? And so
yeah,
can you give folks some example of like what devices that are popular out there that this would specifically be helpful for? They're kind of asking in the chat.
Yeah, so I think on Android phones, basically all recent phones have 64-bit processors, so ARM8 and 9. If you are looking for targeting some IoT board, you need to take a little more care about which one you choose. So you need to take one which has AR64 support, so ARM8 or upward, and it is running in 64-bit mode. That's also important.
And are there any constraints on, say, like memory capacity or speed for this kind of stuff? Like, because there's a lot of different devices out there.
Yeah, basically not. So our routines are small, and our implementation only impacts what is happening inside the CPU. So we are doing different instructions. So yeah, no major memory needs for KleidiCV or anything like that.
Okay, yeah, that makes sense. I think now is a good time for us to do our giveaway. We got about 8 minutes left in the show. So, hey, folks out there, if you're just joining us for the first time, or if you are a longtime viewer and would like a reminder, one of the things we do on this show is a giveaway to you in the audience. I'm about to ask a trivia question based on the presentation from our guest today, and the first person to answer that question correctly in the Zoom chat with your settings set to everyone and not just hosts and panelists. We've had some close ones the last couple of episodes. People are really popping off in the chat for the giveaways. So use the setting to everyone. And if you have won in the last couple of months, please do not answer and give someone else a chance to win. So get ready to answer. One of the things we talked about earlier is the long history of ARM devices. In fact, it was famously used in an Apple product, the Apple Newton, one of Apple's famous failures. In what year was the Apple Newton released? Farad, I'm going to kill you.
The answer came in before.
Okay, Farad, do you have some kind of like, are you monitoring the memory on my laptop? So the answer we're looking for is 1993. Well done, Farad. Congratulations for answering the question before I finished asking it.
So I go to these math competitions for with my son, and there, like they have these buzzer rounds, and before the question is, so they place the question on a screen, and then they have these the person actually reads out the question. All the buzzers, they go off before, right, the question is complete. And the thing is that I was asking my son, he says that the trick is to never listen to this guy, only look at the screen, that
Yeah.
he's a nuisance, right?
Right. It's
So
just distraction. Like you
it's a
actually you
distraction.
want to answer the question. You don't care where it comes from. Like yeah.
Yeah, so they train themselves to actually ignore what this guy is saying and completely focus on the
Yeah, that's for the audience. That's not for
yeah.
the gamers, you know.
That's true. That's true.
Yeah. So yes, 1993. What a year it was. Gosh, what were you doing in 1993, Satya?
Oh, me, I was 13 years old.
I was
So I was
I
doing
was a
whatever
young.
13-year-olds do.
Yeah, but probably not safe for work. How
Right.
about Mark and David? What were you all doing in 1993?
I was 5 only, so I was in kindergarten.
Yeah, wow, yeah, definitely. Now you're making me feel old.
He was learning how to ride bicycles.
Yeah, yeah. Someone in chat just posted Toyota Corolla. I don't know what that means, but I thought it was really funny. We've got a few more questions. We've got a few more questions here, folks. So one from my perspective, so these changes launched as part of OpenCV 4.11, which came out a couple of months ago. What are y'all hearing from developers about this? I know you probably talk to a lot of people on a relatively frequent basis in the community. ARM has a gigantic roster of developers around the world, and all of these, you've got forums and chat services and in-person events and all this kind of stuff. Are you hearing from people in person about these changes now? Or have you had people come up to you and be like, "Oh wow, OpenCV is way faster now"?
To be honest, I'm not, partly because I'm not part of that organization who is facing the partners and those occasions. I do not know about that. On the other hand, we are, from our side, we are more connection with our partners, and there's a few stages here. So there are partners creating SoCs or phone vendors, and then are guys the developers. So it's a challenge to reach the developers on our end. That's why we have this ARM developer program too, where we try to reach those. So please join if you have any experience with this.
Yeah, and we saw a little bit of the demonstrations here today were just some of the performance enhancements. For example, obviously simple stuff like blur and things like that are going to be quicker, but there's also some accelerations for DNNs as well. Can you briefly talk about that here at the end of the show? Had a few questions about it.
Yeah. So we are focusing only the conventional CV part with KleidiCV. So all the AI part is landing on KleidiAI project. And to be honest, I'm not perfectly clear on which framework is used or can be used with OpenCV. So I think there's a high chance that in OpenCV, some other frameworks used, and those other frameworks can have KleidiAI integrated. So that's even more steps to take care of what to use to have the best performance. But I think this is something we can talk about and give you more information on that for OpenCV developers to help you.
Yeah, maybe another episode of the show. Got about 2 minutes left. Get those last minute questions in, folks. I'm doing a quick check over on our LinkedIn, Twitch, and YouTube channels here. People accuse me of not monitoring the chat. I'm watching it. Your questions are just not very good. But we had a few good ones today. I'm going to close it out with one last question here. So there was a lot of questions about the hardware and specific targets, because this is when you're talking about Android, you really do have to think about devices, because it is about the devices. You can run things in a simulator all you want, but you have to put it in somebody's hand at some point, or on the desktop, or whatever you're doing these days. Does ARM have a sense for how many, like a ballpark figure for how many devices in the world extant today these performance improvements to OpenCV are applicable toward? How many millions? It's got to be in the millions, but how many millions? Tens
Devices,
of millions?
billions,
100?
billions, right? With a B. Because
Are there billions of ARM V8s out there? They're possible for Android though, specifically Android, right?
Yeah, it's a good question. Sorry, I cannot answer that. I would also say that this is at the billions of ballpark, because so RB8 is out there for some time. And if you think about for Android phones, they are every year there's a new phone and you need to beat the previous generations. They
right.
have a push to pull in the latest CPUs. So I mentioned the IoT edge small computers like Raspberry Pi and similars. With those, there's not there is that push to reach the latest technology in the market. But with Android, all new phones are V8.
Right. And your slide mentioned that there was more than 20 billion devices in 2023 alone, right? So I'm guessing that 2024 numbers would be similar or slightly more. So that would be a lot of devices.
That is, I think probably the technical term would be a shit ton.
Right.
Another question here before we bounce for the day. Suleiman would like to know, how can people out there contribute to development for KleidiCV and KleidiAI?
I'm not sure about KleidiAI, but I think it's similar to KleidiCV. We are welcoming contributions, so we have a public GitLab instance. We do all our development in public, so you can see our current merge requests on flight. And yeah, thank you for posting into the Zoom chat the link. I think, guys, you also get. But if you check gitlab.arm.com, and you can search for KleidiCV.
Yeah, that's right. gitlab.arm.com. We'll make sure that we drop the links in the show notes here on YouTube, which is where most people will probably see this. Hi, if you're watching this tomorrow or next week or next year. Doc, I think it's time to go home. You want to take us home?
Yeah, thank you so much, David and Mark. It was a pleasure having you on this show. And, our community is really grateful for all the improvements you have made, because, we did the integration, but the heavy lifting has been done by the ARM team. And so we are really grateful for them. And with that, I'd like to thank our audience. I'd like to thank you both. And above all, I want to thank Phil Nelson for organizing this show. Thank you, guys.
Yes, and above
Thank
all,
you.
I would like to thank the viewers. Thanks for watching this show. We really appreciate it. We will see you next Thursday, same bat time, same bat channel, 9 a.m. Pacific time. Our guests, I believe, will be the folks from Voulez-Vous if they have launched. So look forward to Voulez-Vous. That'll be fun. This was another one. Just you meet interesting people sometimes, and they come on the show. Do you want to quickly tell the folks a little bit about Voulez-Vous, Satya?
Yeah, so Voulez-Vous is an app which was developed by one of the OpenCV University students. So when we launched the generative AI course for art, we thought that, okay, this is just a fun course. This is not like a 3-month course. Most of our courses are 3 to 4 months, which are foundational courses. But generative AI course was like a weekend course, right? You can complete that in over 2 weekends. And I frankly did not know how useful it would be, but turns out that this company, Voulez-Vous, they use generative AI to create cocktail images. So the Voulez-Vous app takes a picture of the alcohol you may have in your house, and it will tell you what are the different cocktails you can make. The challenge is that it's a small team. How do you create images of those cocktails, right? It can be very expensive. If you have 10,000 different cocktails to create those images, it's very expensive. So they use
just one liver per person.
Oh, that's right. That's right. So they fortunately, one of the founders is a mixologist. So they took picture, they created the picture, and then the mixologist was able to verify that this picture is correct. And sometimes they had to create several images, and they would pick the right one, change the prompt, and so on. And then they used also several other OpenCV techniques to center the image, to produce. So they'll describe all those in the next session. But yeah, I mean, I was so glad because this app I was able to try it out at my own home, and so it was a pleasure to see this somebody using the things that we teach in our courses and then bring it to the real world. A very small team, right? Too. So that was a pleasure to
Fantastic.
see.
Yeah, super gratifying to see the folks out there, what y'all make. And as a reminder, we do have a very public OpenCV. If you have made something cool using OpenCV, or you're just a fan of this show and made something cool, maybe that doesn't necessarily involve OpenCV, send it to us to newsletter@opencv.org, or you can send it to the OpenCV Cool Stuff form, and we will surface some of those on our social medias, in the OpenCV newsletter, etc., etc. But that's it for today. Take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be.
All right. Thank you, guys.